In the next two examples, we're going to look at factoring to solve quadratic equations. Factoring is generally the easiest method to solve quadratic equations, although sometimes you'll run into the odd quadratic equation that's very difficult for you to factor using integers, in which case you might use one of the techniques in the notes, such as the quadratic formula. In this first example, we're looking for two numbers that multiply together to give us positive 12, yet add to give us negative 7. Those two values are negative 3 and negative 4. This indicates that we can factor our quadratic equation into the following binomial pairs. Now, since we have a product of two numbers that are equal to 0, it must be that either the first number is equal to 0, or the second number is equal to 0. And solving these two linear equations gives us x is equal to 3 and x is equal to 4. So here are the two values that will satisfy our original equation. Now, what if we have something that's a little bit messier like this? Well, we know it's quadratic because the highest power of our variable x is 2. This indicates what we should do first is try to get this into standard form and see if we can factor the resulting quadratic expression. First, let's add 2x squared to both sides. Next, we can subtract 30x from both sides, and this is going to give us 9x squared minus 30x plus 20 is equal to negative 5. Now we still don't have its standard form because the right-hand side is not equal to 0. So in order for us to get standard form, we're going to add 5 to both sides. And that's going to give us 9x squared minus 30x plus 25 is equal to 0. Recall, to factor a quadratic expression where a is not equal to 1, we're going to list our factor pairs of 9 and 25. So I've gone ahead and done this in the bottom left. And remember, we're looking for a sum that is going to give us 30. Wading through the possibilities, you should see that the 3's and the 5's should give us that 30 that we need if we arrange them in the following way. Notice that the multiplication of our first two terms indeed gives us the 9x squared, and the multiplication of our last two terms does give us the positive 25. Our two outside terms here will give us negative 15, and our two inside terms will also give us negative 15 for an overall value of negative 30x. Because we have two numbers multiplied together that are equal to 0, it must mean that either this number is equal to 0, or this number is equal to 0. Well, since 3x minus 5 is the same as 3x minus 5, there's only one possibility here. 3x minus 5 is equal to 0. This means that 3x is equal to 5, and x must be equal to 5 over 3. This is the only solution to our original quadratic equation.